We're now going to talk about scales of measurement. And scales of measurement is, it's not further breaking down the types of variables. It's not like taking discrete and continuous and breaking them down. The idea is that every variable has a certain scale of measurement. And there's 4 scales of measurement, and depending on the scale of measurement, that will determine the type of methods that you can and can't use. And this is kind of abstract here, and the idea is that each scale, you start with a really simple scale, and the scale is kind of like it's the capability of that variable to measure something. So different scales have different capabilities. The very first one is very, very simple and it can't measure very much. And then each time you add something to the scale to make it more and more versatile, more capable of measuring. And so I like to think of this as a stair step. And I'm not going to sit and define every one of these. Your textbook does a good job of that. I just want to give you a short description of what these are and how to identify which scale of measurement is being used. So first of all, the 4 scales are nominal, ordinal, interval, and ratio. Okay, so here's the idea. Nominal is the simplest scale of all, and it really can't measure very much. It has different categories, and you either belong in one category or another category. So this might be political party, marital status, things like that. So these are very much like the qualitative variables, and in fact they are qualitative. Okay. Now the difference between nominal and ordinal as you go up the scale is that the ordinal scale of measurement adds order to these categories. So these categories don't necessarily have a natural ordering to them. And so that's what ordinal adds. So you could say adds order. And so some examples here might be freshman, sophomore, junior, senior. Okay, these are natural categories. If I had these categories, you would naturally put them in that order. Another one might be small, medium, large, extra large, something like that. Small, medium, large, extra large. Again, these are different categories, but they have a natural ordering to them. Okay. Now what these don't have is there's no distance between them. And for that reason, I can't do any sort of arithmetic. Like I can't take a large and subtract a medium and then get a small. I mean, none of that makes any sense. Or I can't take a senior, subtract a junior, and get a freshman or something. That doesn't make any sense. Okay? So what does interval add? It adds distance between the categories, and now you can find how far apart different categories are. Now before I actually give some examples of these, let me tell you that what ratio adds is a little strange at first, but it's going to make sense in a minute. But what it adds, the ratio scales adds, we're going to call it an absolute 0. Okay, and this will make sense in a minute. Okay, so let me give you some examples of ratio first, and then and then I'll give you some examples of interval and tell you why they're not ratio. Okay, so examples of ratio would be things like someone's height, someone's weight, it could be like the time it takes to complete a task, the distance that you travel. So all kinds of things, okay, are ratio. Now, what's interval? What's something that's on an interval scale? Well, an interval scale is a scale where it's not clear where 0 is. So take temperature, for example. If you're measuring someone's height, 0 is like the beginning when you haven't started measuring, and then you can measure different heights, but you're measuring from 0. And 0 in that scale is an absolute 0. But in temperature, okay, what they did is they had to choose some temperature to be 0, right? And then they measure from that. So like in the Celsius, 0 degrees Celsius is the freezing point of water, right? But in the Fahrenheit scale, the freezing point of water is 32 degrees Celsius. So whoever came up with the Fahrenheit scale just chose a different temperature that's actually below the freezing point of water to be 0. And then they're measuring from that temperature. So in a sense, these are like arbitrarily chosen zeros. They're not absolute zeros. They didn't have to be chosen for what they are. It's just you have to start somewhere and you measure from that. Okay? So we can have temp in degrees Celsius or degrees Fahrenheit. That's an example. Another example would be the date, i.e., when we say like 2021. Okay? When we say it's year 2021, well, we had to choose some other year in history to be 0, and then we're measuring from that, right? And like with temperature, if you're above 0, you're positive. If you're below 0, you're negative. And then with the date, it's actually AD and BC. Okay? And so it's the same idea, though. They had to choose a year. And the reason they have to do that is who knows when year 0 was? Nobody really knows when everything began. So they have to choose some date in history, and they have to measure from that, right? And that's the best that they can do. So another example might be altitude. Okay? And in altitude, you're like so many miles above sea level. So sea level is kind of the arbitrarily chosen 0, and you're either above 0 or like New Orleans, you're below 0. You're below sea level. But you're choosing sea level to be like your 0, and you're measuring from that. I mean, you have to choose somewhere to be 0 in order to measure from that. And so all of these, what makes them an interval scale and not a ratio scale is they are arbitrarily, I don't know if I spelled that right, chosen zeros. These are arbitrarily chosen because you had to start somewhere and then you're measuring from that. But in the ratio scale, these are interval scales that have an absolute 0. And so they're not arbitrarily chosen. It's not like I chose 2 feet to be 0, and if someone's 5 feet, I say they're 3 feet tall, right? But if they're 2 feet tall, I say they're negative 1 feet or something like that. I mean, those that doesn't make any sense. These are absolute zeros. That makes them a ratio scale. Okay? And so each scale then is adding something. Okay, so nominal is the simplest one of all, and you just have different categories. You belong in one category or the other. Ordinal adds order to them, so you can say that one category is before or after the other, something you can't do here. Interval actually gives a distance between values so that you can tell how far apart they are. Okay, and then ratio, and in interval scale, let me say that different sums and differences make sense, but actually taking ratios does not make sense in an interval scale, and that's kind of an interesting thing. It's a little abstract, and if I have time, I can show you something at the end here. Ratio scales, they add an absolute zero, and now ratios make sense. It's like you have to have that absolute zero for ratios to make sense. Okay, so now how do I identify what the scale of measurement is? Here's the way to do it. The real easy way is I split my staircase in half. On this side we have qualitative variables, and then on this side we have quantitative variables. So what you're doing is you're first deciding if it's qualitative or quantitative. And then if it's qualitative, you're just deciding whether there's a natural ordering to them or not. If there is, it's ordinal, and if there's not, it's nominal. So if it's a quantitative variable, then what you're doing is you're just asking about zero. Was it arbitrarily chosen, like these examples? And these are kind of harder to find. Or was it an absolute zero, like these? And depending on that, you determine whether it's ratio or interval. Okay? So just do it in two steps. First, decide qualitative, quantitative, and then ask if it's qualitative, is there an order or not? If it's quantitative, is zero arbitrarily chosen or absolute? Okay? And that'll get it for you every time. So what I want you to do here is I want you to take these same variables from before, and I want you to determine which of the 4 scales of measurement each variable is. So go ahead, press pause, and then you can start it back up again and see how you do. Okay, so let's see how you do. So the time it takes you to read chapter 1 of your stats textbook, that is a ratio scale. Okay, the time it takes you to do a task is ratio. Okay, 0 is when the task begins, right? Absolute 0. The thickness of your stats textbook, that's ratio. Okay, so oftentimes quantitative variables are ratio. The number of pages in your stats textbook, that's ratio. Okay, the topics covered in chapter 1 of your stats textbook. So in this case, that's a qualitative variable here. So now I'm on this side, and the topics covered don't have a natural ordering to them. Different textbooks will order them in a different order. So this is a nominal. Okay. Edition of your stats textbook. Okay. Again, we remember before we said the addition was qualitative because you can't add or subtract them. Okay, so in this case, though, the edition has a natural ordering to them. They came out in an order: the first edition, second edition, third edition. So that's ordinal. So that's an example of ordinal. The temperature of your stats textbook in degrees Celsius, well, that's interval. Okay, degrees Celsius. Okay, now what about degrees Kelvin? Okay, so if you know from your physics class or whatever, Kelvin is a scale for temperature that has an absolute 0. So what happened is, as science progressed, people realized that the temperature of an object was the kinetic energy in the molecules. It was how fast they were moving. The faster they move, the hotter it was. If you touched it, it would hurt because it's moving really fast, and your hand, it's not, the molecules in your hand are not moving as fast, and that's where you get the pain. And so if that's the case, if the temperature is the kinetic energy in the molecules, then there must be a temperature, or there must be, when the molecules are at rest, where you can't be any less than that, right? The kinetic energy cannot be any less. And that is known as absolute 0. And it's interesting because it's like a negative 273 degrees Kelvin or something like that. And so there is an absolute 0. So in other words, degrees Kelvin is a temperature scale that's in degrees, a temperature scale that's ratio. So when it's in Kelvin, it's ratio. Okay, the amount of money you paid for your stats textbook. Again, that is ratio. Okay, that's a ratio scale. And now this one was my attempt to come up with another interval scale. The opinion of your stats textbook on a scale of 0 to 10, with 0 being strongly disliked, 10 being strongly like. Well, in this case, 0 doesn't mean like no opinion or really, really, really dislike. Or, I mean, 0 is arbitrarily chosen in a sense, right? And you're measuring from that. So 0 is a arbitrarily chosen, really, really dislike, and then you go up from there. This last one, though, I like this one because it's interesting because there's a lot of people who would claim that when you ask someone to name something on a scale of 0 to 10, this doesn't do any measuring at all because it's subjective. So when you say something's an 8, I may say that it's a 5. You know, I'm a stats teacher, so you might think it's a great book, but I know better, or something like that. And so when you give your opinion on a scale of 0 to 10 or whatever, it's subjective, and they would say that doesn't really measure. And so if you wanted to capture how people felt about the textbook or whatever, you would need a objective way to do it. And so here's an example. Let's say you had 10 different things that someone could like about the textbook or whatever. You had 10 different things, and they chose which things they liked about it, and then their opinion of the textbook, you could think of it as being on a scale of 0 to 10, 0 meaning they didn't like anything about it, 10 meaning they liked all 10 things about it. And in that case, if that's how you measured it, then you would have an objective scale, you know, and the scale would measure how many different, out of the 10, how many different things the different people liked about the textbook, and it would be a ratio scale in that case. It would also be a discrete variable because you're counting the number of things that they liked. Okay, so that's an interesting example to have, and it makes you think. So one last thing that I want to talk about before I move on is why you need an absolute 0 in order to be able to compare ratios. Okay, so here's 2 different scales. Okay, and on this scale they chose this temperature, whatever it is, to be 0 degrees, and on this scale they chose this temperature, whatever it is, to be 0 degrees, and then they're measuring from that. Okay, and to make it simple, the steps on the scales are the same. Okay, so the steps on the scale are not, the units on the scale are not the same when you're comparing Celsius and Fahrenheit. Okay, but in this example, we'll say that they are the same. Okay, well, in this case, it would make sense then. The differences would make sense. This has an arbitrarily chosen 0, so this is an interval scale, but differences make sense. So on scale 1, 30 degrees minus 10 degrees would actually give you 20 degrees. Okay, on scale 2, 30 degrees would be 40 degrees, right? And 10 degrees would be 20 degrees. And you could take 20 minus 40, but you still get 20 degrees. Okay, so differences are consistent. So the differences actually make sense. Okay, but if I compare these 2 values with a ratio, scale 1, I would get 30 degrees divided by 10 degrees. I'd get a 3, which would mean on this scale, 30 degrees is 3 times as much as 10 degrees. But on scale 2, 40 degrees is twice as much as 20 degrees. Okay, and so the ratios are not consistent. Okay, and so that is why you need to, in order for the ratios to be consistent, you need an absolute zero. Okay, so you can't use any statistical method that uses ratios to make comparisons, you would need a ratio scale. Your variable would have to be a ratio scale. So this is pretty abstract. This is not anything you have to worry about. It's not going to be on the homework or the test. But that is why the absolute zero is important and why there's that difference between the two scales.